Hi guys, in the last video we looked at some of the reactions of cobalt, and now we're going to be moving on to talk about chromium chemistry. So in aqueous conditions, an equilibrium can be established between two of the ions that chromium commonly appears in. We have our chromate 6 ions, and the Vi, which means 6 in Roman numerals, stands for the oxidation state of the chromium within this ion. So the chromium is 6+, but then we also get 6+ chromium in dichromate ions. The conditions that this equilibrium exists in dictate whether it's going to lie to the left or to the right. So if we have acidic conditions, which means that we have lots of H+ ions, then this equilibrium is going to move away from the left side towards the right side and form more of the dichromate. So if we made a solution more acidic, we'd expect to see it get more orange because the dichromate ions are orange. If, on the other hand, we made it more alkali, then what that's going to do is reduce the number of H+ ions, and so the equilibrium is going to move, because of Le Chatelier's principle, to form more of the left-hand side products to replace the H+. This means that we're going to get more chromate, and we would see the solution turn more yellow. Chromate and dichromate ions will also undergo redox reactions. So whereas above we saw that in both cases we have an oxidation number of 6, if we carry out redox reactions, this oxidation number is going to change, and we're going to get things like chromium 3+ or chromium hydroxide, which also has an oxidation number of 3+. We can investigate these reactions using electrode potentials, and that's what this table summarizes. We have the half equations for the reduction of both the chromate and the dichromate ions, and we're going to see how hydrogen peroxide can cause this reduction or oxidation. The specific example we're going to consider is the oxidation of chromium hydroxide, so we're going to be forming the chromate ions. Remember that the lower a reaction is in these sort of tables, where we have the more negative electrode potentials at the top and the more positive ones at the bottom, the more positive ones are more likely to favour the forward reaction, which is reduction, and the ones higher up in the table with more negative electrode potentials are more likely to be oxidised. What this means is if we mix hydrogen peroxide with chromium hydroxide, then we have a system where the hydrogen peroxide wants to...
Hey guys, to continue watching this video and unlock hundreds of other super concise exam board specific A-level chemistry videos, just click the snap revise smiley face here. Join me today and together let's make A-level chemistry a walk in the park.